Hi, my name is Rick Eads. I work for Addin Technologies. This is a series of videos where we're going to be talking about PCI Express 3.0. PCI Express 3.0 will usher in a new generation of test fixtures, and that's what I'd like to talk about in this segment. The first test fixture I'd like to talk about is what we refer to as our compliance baseboard, or CBB. The compliance baseboard for Gen 3 is a little bit different from the one that we had for Gen 2, but is very similar in a lot of regards. One of the biggest things you'll notice about it being different is this board on this side, which is an ISI or inter-symbol interference channel board, which represents the worst case channel for PCI Express 3.0. I'll go into a little bit more detail in a minute. The next fixture I'd like to talk about is the new compliance load board for PCI Express 3.0. Now, this board is almost exactly the same as the board that we used in PCI Express 2.0, but there are a couple notable exceptions, and we'll go into that in a little detail in this next part of the segment. This is the compliance baseboard for PCI Express 3.0. Now, there's a couple of differences between this board and the board that we used for PCI Express 2.0 that I'd like to point out. First off, the compliance point for the card electromechanical specification, or chem spec, is at the connector. This represents the point where if you have an Addin card, such as a graphics card or host bus adapter, you're going to want to plug that in. So the reason why we have this as the compliance point is this is the point of interoperability. We want to make sure that if you purchase a card from one vendor and a host or root complex device from another vendor, that they're going to interoperate, and that interoperation starts right here. Here on this side we have the transmit outputs, and one of the things that we've done for PCI Express Gen 3 is we have added SMP connectors with a limited detent, and this helps to retain the cables that we use for testing. Also of note is we have now a switch that allows us to switch between using the onboard reference clock that's provided by these Peckel oscillators, or to use an external reference clock provided by another source. Now, where this starts to play a role is when we're doing bit error rate testing, where we drive the clock into the board from an external source like a BERT. We've got a similar switch circuit that we use to switch the device between different compliance modes, and instead of tying that signal directly to the lane 0 of the RX input to the chem device, we actually have broken that out now, so the signal that's used for toggling is here externally. That gives us a much cleaner RX lane 0 than what we had with the Gen 2 platform. The benefit of this is that we have one compliance board for Gen 3 that we can use for both TX testing as well as RX testing. So what we would do here in operation for TX is we would connect these two SMPs to lane 0 up here on the receive side. Now you'll notice on the receiver board we've got two connectors, and then the 20 inches of trace, or about 45 centimeters of trace. That represents the worst case channel that provides us with inter-symbol interference and loss that is necessary to perform the receiver testing for PCI Express 3.0 endpoint devices. This board is the compliance load board for PCI Express 3.0. Now, this particular board is configured to support a by 16 or a by 1 configuration for lane testing. There's another board that's also available that will do either by 8 or by 4 testing. So we have two boards. One is for by 1 by 16, one is for by 8 or by 4. On this side we have the transmitter outputs, and the way that this particular board is configured, we already have the transmitter the transmit cables connected to lane 0 of the transmitter. Now, I had mentioned before that we use limited detents, so if you can see that these particular cables, as we put them in, actually click in there very nicely, so they're well retained. And this is very handy when you're working with server class motherboards where you have different orientations, not necessarily 90 degrees on the slot. Now, on the output, just like for PCI Express 2.0, we have these two SMPs that allow us to extract the reference clock from the root complex device, and that's used for two-port testing, which is a fundamental element of both PCI Express 2.0 as well as PCI Express 3.0. New to this fixture, though, is a switch, where we used to have jumpers that would allow us to configure whether we would allow the reference clock to be transmitted on these SMPs for output for testing, or to be utilized for transitioning the device from into different compliance modes. We'll talk more about that in a later section of this series, but I just wanted to point out that just like on the compliance baseboard, we take the signal that we use to toggle a PCI Express device to different compliance modes, and we feed that directly via these external SMA cables into lane 0 of the device. The benefit of doing that is when we're not using this card for transmit testing, we can then use it for receiver testing. We don't have to make any type of physical modification of the board. PCI Express 3.0 signaling runs at 8 gigabits per second, and this series deals with a lot of the elements of testing a PCI Express 3.0 transmitter. For more information, see the website that appears at the bottom of the screen.